What comes to your mind when you hear Pluto? Ice? Controversy? While Pluto is known for the two things mentioned here, the celestial body is much more than cold temperatures and arguments about its true nature. And this is why scientists studying this distant space object continue to be amazed by the fascinating discoveries they find. What insane new discoveries have scientists discovered from new images taken from Pluto? What does Pluto tell us about the solar system and the origin of Pluto? Join us as we dive into what new images taken of Pluto shockingly reveal. The story of Pluto is that of demotion and loss of cosmic prestige. This space object once had the status of a planet, but later got demoted to planetoid. What really happened to Pluto? Pluto is unique in many fascinating ways. One of them is how it got its name, from an 11-year-old schoolgirl in England named Venetia Burney. The Lowell Observatory discovered Pluto, earning it the right to name the new object. However, it received over 1,000 suggestions from all over the world, including Pluto from Burney. She was fascinated with classical mythology as well as astronomy and thought the name for the god of the underworld was appropriate for such a presumably dark and cold world. She mentioned it in a conversation with her grandfather, Falconer Maydan, a former librarian at the University of Oxford's Bodleian Library. Maydan passed the name to Professor Herbert Hall Turner, who then cabled it to colleagues in the United States. Pluto officially became Pluto on March 24, 1930. The name was announced on May 1, 1930, and Venetia received £5 as compensation for her effort. Interestingly, the name Pluto honors Percival Lowell, who founded the Lowell Observatory, because the first two letters are his initials. So who discovered Pluto? That achievement is credited to Clyde Tombaugh, a 23-year-old Kansan who just got employed at the Lowell Observatory, although he got assistance from other scientists. American astronomer Percival Lowell was the first to suspect Pluto's existence in 1905 from odd deviations he observed in the orbits of Neptune and Uranus, implying that another world's gravity was tugging at these two planets from beyond. Lowell predicted the mystery planet's location in 1915, but died without finding it. Pluto was finally discovered in 1930 by Tombaugh at the Lowell Observatory, based on predictions by Lowell and other astronomers. Pluto is one of the largest known objects in the Kuiper Belt, a shadowy zone beyond the orbit of Neptune, containing hundreds of thousands of rocky, icy bodies, each larger than 62 miles or 100 kilometers across, along with 1 trillion or more comets. A recent photo analysis revealed a rough patch on Pluto that is unlike anything else on the small world or in our cosmic vicinity. This lumpy region is home to a smattering of unusually enormous ice volcanoes unlike anything else we've ever seen in the solar system. The location is southwest of the Sputnik Planitia ice sheet, covering 621 miles 1,000 kilometers of the ancient impact basin. It mostly consists of lumpy water ice and is covered in volcanic domes. Wright Mons and Piccard Mons are two of the largest. Piccard Mons is around 22,965 feet 7 kilometers high and 139 miles 225 kilometers wide, whereas Wright Mons is roughly 13,123 to 16,404 feet 4 to 5 kilometers tall and spans 93 miles 150 kilometers. The Mauna Loa volcano in Hawaii is one of the largest volcanoes on Earth, and Wright Mons is thought to be comparable in size. Some of the domes seen in the photos combine to form even larger mountains, but what may have caused them to exist? It all boils down to ice volcanoes. Ice volcanoes have been discovered in other parts of the solar system. They produce a new landscape by moving material from the subsurface to the surface. When the water reached the freezing temperatures of Pluto's surface, it swiftly turned to ice. Pluto's snow-covered mountains look like they belong on Earth, but they are in fact completely different from our own planet. It's hard to compare the appearance of these features to any other volcanoes in the solar system, be it icy or rocky. They started out as mountains, but there is no caldera at the top, and they are covered in big bumps. Pluto is very far from Earth, so understandably, little was known about its size or surface conditions until 2015. Pluto has a diameter of 1,473 miles, or 2,370 kilometers, less than 1/5 the diameter of Earth, and only about 2/3 as wide as Earth's moon. So Pluto is almost half the width of the United States. Pluto's surface is one of the coldest places in the solar system at roughly minus 387 degrees Fahrenheit or minus 232 degrees Celsius. Also, when scientists compared pictures of Pluto taken by the Hubble Space Telescope, they realized that the dwarf planet had apparently grown redder over time. They suggest this change was apparently due to seasonal changes. Pluto has a highly elliptical orbit that takes it more than 49 times as far from the Sun as Earth. Due to the eccentricity of its orbit, Pluto's distance from the Sun varies significantly. The dwarf planet gets closer to the Sun than Neptune is for 20 years out of Pluto's orbit, which is equivalent to 248 Earth years. As a result of that orbit, after 20 years as the 8th planet, counting from Mercury, in 1999 Pluto crossed Neptune's orbit to become the farthest planet, in quotes, from the Sun. At the closest approach, or perihelion, Pluto is 2.75 billion miles from the Sun and 4.54 billion miles away at the farthest of aphelion. Pluto is blessed with 5 moons: Charon, Styx, Nix, Kerberos, and Hydra. Charon is the closest to Pluto, and Hydra is the most distant. Pluto has a very large moon, nearly half the dwarf planet's own size. This moon was dubbed Charon after the mythological demon who ferried souls to the underworld in Greek mythology. Because Charon and Pluto are so similar in size, their orbit is unlike that of most planets and their moons. Both Pluto and Charon orbit a point in space that lies between them, similar to the orbits of binary star systems. So scientists refer to Pluto and Charon as a double dwarf planet, double planet, or binary system. Pluto and Charon are just 12,200 miles, or 19,640 kilometers apart, less than the distance by flight between London and Sydney. The Earth and the Moon are separated by 384,000 kilometers in comparison. Charon completes an orbit around Pluto in 6.4 Earth days, and one Pluto rotation, that is a Pluto day, is similarly 6.4 Earth days. This is because Charon hovers over the same spot on Pluto's surface, and the same side of Charon always faces Pluto, a phenomenon known as tidal locking. Pluto is known for its ice, but what happens to Pluto if it gets close enough to the Sun? If it did ever get close enough to the Sun, much of the surface ice would eventually thaw, and its atmospheric layers would be at their thinnest, lacking much of its carbon monoxide ice, but mostly retaining its nitrogen and a little bit of methane. At that point, scientists might consider Pluto to be in its most habitable form. Although we have no idea what to do about its low gravity, which is about 1/20th of the Earth's. Hence, its atmosphere appears much denser and higher than Earth's, and the further it strays away from the Sun, the denser it becomes as the atmosphere freezes until it phases out of view. When considered at its thinnest, scientists have surmised that it restricts the flow of fluids. One proof of this is provided by the New Horizons in an image of a frozen lake in the Tombau Regio. They also saw what looked like water channels. We join them in thinking about the possibility of the planet having an atmosphere 40 times denser than the red planet, talking about Mars, of course. There were also observations of certain cloud forms in the atmosphere. The clouds were formed at low altitude with technically the same sizes, but the major components of these clouds are thought to include acetylene, ethane, and hydrogen cyanide. So why did Pluto lose its status as a planet? When Tombaugh discovered Pluto, textbooks were immediately updated to include this 9th member in the club. However, over the ensuing decades, astronomers began to question whether Pluto might simply be the first of a population of small icy bodies beyond the orbit of Neptune. This region would become known as the Kuiper Belt, but it was not until 1992 that the first occupant of the region was discovered. The candidate Kuiper Belt object KBO 1992 QBI was detected by David Dewitt and colleagues using a ground-based 2.24-meter telescope at Mauna Kea. The discovery of the first KBO escalated the existing debate on the planethood of Pluto. In 2000, the Hayden Planetarium in New York became a focus of controversy when it unveiled an exhibit featuring only 8 planets. The planetarium's director is Neil deGrasse Tyson, everybody's favorite astronomer. Pluto's days as a planet became numbered with the discoveries of Kuiper Belt objects with masses roughly comparable to Pluto, such as Quaoar, Sedna, and Eris. Eris in particular appeared to be larger than Pluto, making some astronomers honor it with the informal title of the solar system's 10th planet. Drama ensued when the International Astronomical Union set up a committee to define just what makes a planet a planet. Incredibly, the first effort of the committee would have increased the number of planets in the solar system to 12 because Pluto and its moon Charon were recognized as twin planets, and Ceres and Eris were granted entry to the exclusive club, but the idea met with opposition. Eventually, the committee set 3 criteria that a planet must meet, and this dealt a huge blow to Pluto's standing as a planet. The conditions were: 1. A planet must orbit the Sun. 2. A planet must have sufficient mass for its self-gravity to overcome rigid body forces and assume a round shape. And 3. A planet must have cleared the neighborhood around its orbit. Pluto met the first 2 of these criteria, but the last one proved thorny. Clearing the neighborhood means that the planet is either vacuumed up or expelled other large objects in its vicinity of space. So basically, it has attained gravitational dominance. Unfortunately for Pluto, it shares its orbital neighborhood with other icy Kuiper Belt objects, so the resolution effectively stripped the distant world of a planetary designation it had held for some 76 years. It was immediately demoted to the status of dwarf planet. But of course, this move presents some rather interesting cosmic conundrums. For instance, the Earth shares its orbital turf with more than 12,000 asteroids. The same with Jupiter and other planets. Does that make the Earth unplanetary? To rub it in the face of Pluto, the international scientific community recognizes Pluto's historic downgrade with a holiday called Pluto Demoted Day every August 24th. Worse still, the American Dialect Society voted Plutoed as the word of the year, with the meaning being to demote or devalue someone or something. Let's talk more about the ice on Pluto. For decades, scientists believed that Pluto's stony core lacked the internal energy necessary to stoke volcanoes. They believed that several eruptions would have been required to form the area. Additionally, the lack of impact craters in the area, which can be observed across Pluto's surface, shows that the ice volcanoes were active very recently and that Pluto's interior has more residual heat than expected, implying that our understanding of planetary systems is incomplete. As far as geological timescales go, the ice volcanoes may have been active as recently as 100 million or 200 million years ago. Observing Pluto's ice volcano would be an experience unlike anything you've ever seen before. On this dwarf planet, instead of erupting gases and molten rock, the cryovolcanoes on this dwarf planet expel massive amounts of ice, most likely frozen water. While flowing out of its volcanic vent onto Pluto's surface, the frozen material would most likely be a slushy mix of ice and water, or more like toothpaste. The explanation for this is that liquid water cannot last long on Pluto's surface due to its extreme temperature. In any event, the flow of material created the gigantic domes that we see today and the bumpy topography that can be observed across this region. The team working on New Horizons was only able to observe the region for about a day as it flew over this region. Therefore, they were unable to observe any present ice volcano activity. In theory, the ice volcanoes could still be active at this time. They could be like Earth's dormant volcanoes, which become active again after a period of inactivity. How did Pluto form? This is quite interesting and takes us back to the formation of the solar system itself. Approximately 4.6 billion years ago, the solar system was a cloud of dust and gas known as a solar nebula. What happened next was that gravity collapsed the material in on itself when it began to spin. The sun then formed the center of the nebula. However, not all the materials went into the formation of the sun, and the remaining pieces began to aggregate. Small particles started pulling together thanks to the force of gravity and formed larger particles. The lighter particles got swept away by solar, leaving only heavy rocky materials to create smaller terrestrial worlds. But as we move further away from the sun, the solar winds had less impact on lighter elements, and they began to coalesce into gas giants. This is how asteroids, comets, planets, and moons were born. Scientists say Pluto's rocky core was the first to form under this scenario. From there, gases and ices would have been pulled in gravitationally, with the core growing larger and larger. But like the other dwarf planets, Pluto failed to gather enough mass to reach the classification as a full-scale planet. Some scientists once called Pluto a Neptune reject. The early days of the solar system were really chaotic, with planets, dwarf planets, and asteroids scattered all over the place. However, order started to appear as the planets traveled through their paths. Their significant mass gave them a great deal of gravitational power, allowing them to change the orbits of smaller bodies. Some of the smaller bodies were catapulted into the sun, while others were cast out by the solar system completely. It was Pluto's bizarre orbit that made many astronomers conclude that it was once orbiting Neptune before being kicked out. However, Pluto's orbit is such that it can never collide with the large planet, meaning that it could not have once been part of its system. There is something else scientists have come to conclude from the ice of Pluto. In addition, some scientists believe that Pluto has a liquid ocean beneath its ice cover that is around 249 miles thick. According to this theory, Pluto's moon Charon developed later in the dwarf planet's existence as radioactive materials decayed near the rocky core. A subsurface ocean could have formed as a result of this heat. Contrary to popular belief, however, the data from New Horizons suggests otherwise. According to new research based on that data, Pluto may have been formed in a heated formation scenario. Those extensional fractures detected by New Horizons in Pluto's ice surface could be caused by the gradual freezing of the liquid ocean over time. These ice volcanoes may indicate that Pluto's once prominent subsurface ocean is still present and that liquid water may be present within a short distance of the planet's surface. In conjunction with previous findings of Pluto's interior being warmer than previously thought, these new findings raise intriguing questions about Pluto's potential habitability. However, other scientists claim that any organism attempting to thrive there will face numerous difficulties. Even if the volcanism is episodic and hence the availability of heat and water is intermittent, life would still require a constant source of nutrients. Sending an orbiter to Pluto to investigate its fascinating subsurface would be necessary. We may utilize ice-penetrating radar on a future expedition to see directly inside Pluto and observe what the volcanic plumbing looks like. Scientists are set to learn more about Pluto thanks to the new James Webb Space Telescope. Even though its main job is looking into the billions of years of the universe's history and searching for exoplanets, that is, planets outside the solar system, it can also be trained on planets within the solar system. NASA used Jupiter during the testing of the JWST, and even though the images captured of the Jovian planet didn't get the full treatment or image processing, it is still stunning the amount of details captured. A view from the NIRCam instrument's short wavelength filter shows distinct bands that encircle the planet as well as the Great Red Spot, a storm big enough to swallow the Earth. The iconic spot appears white in this image because of the way Webb's infrared image was processed. Clearly visible at the left is Europa, a moon with a probable ocean below its thick icy crust and the target of NASA's forthcoming Europa Clipper mission. What's more, Europa's shadow can be seen to the left of the Great Red Spot. Other visible Jupiter moons include Thebe and Metis. Scientists were excited by these images because they prove that JWST could see the satellites and rings near bright solar system objects such as Jupiter, Saturn, and Mars. In fact, scientists are waiting to use the JWST to confirm if we can see plumes of material spewing out of moons like Europa and Saturn's moon Enceladus. The powerful telescope may be able to see the signatures of plumes depositing material on the surface of Europa. So if you're a fan of Pluto, you're allowed to be excited by what the JWST will discover on the dwarf planet. However, before that, New Horizons has been instrumental in expanding our knowledge of icy Pluto. The spacecraft also revealed the unusual mechanics of Pluto's beating heart-shaped glacier, which is about the size of Texas and even helps generate the planet's wind. The heart-shaped feature is known as Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. Nitrogen ice dominates this part of the dwarf planet, which is home to the deep basin known as Sputnik Planitia due to its elevation of 1.9 miles below the planet's surface. The basin is the left lobe of the heart, with nitrogen glaciers and highlands on the right side. Pluto's frozen nitrogen core thaws enough to turn into vapor throughout the day. It begins to freeze over again at night. Scientists refer to this as Pluto's heartbeat, which regulates nitrogen wind circulation in the planet's atmosphere. The wind is created when Pluto's frozen heart beats. Because expansion would occur throughout Pluto's history, this protracted, progressive freeze of the subterranean ocean could also explain the variety of characteristics on the dwarf planet's surface. Pockmarked surfaces were also found on Pluto and Charon in photos taken by New Horizons. Large craters dot the landscape. It appears from the craters that Pluto and Charon were struck by small Kuiper Belt objects less than 100 kilometers in size. The fact that no impact craters smaller than 13 kilometers in diameter were identified suggests there are fewer Kuiper Belt objects smaller than 2 kilometers that astronomers had projected based on what scientists know about impact crater formation. This lends credence to the theory that Kuiper Belt objects may not be chunks of space rock generated by collisions, but rather unbroken leftovers from the formation of the solar system billions of years ago. Also, the dunes on Pluto are only one of the planet's many surprises. On Pluto, the dunes are not composed of sand like that of Earth, but of solid methane ice grains that are molded by the wind. Dunes are more common than you might expect in our solar system. They exist solely on Earth, Mars, Venus, Saturn's moon Titan, and comet 67P. Due to the fact that these dunes are mostly undisturbed on Pluto's frozen crust, it's likely that they were produced within the last 500,000 years, or perhaps less recently. Pluto creates an age-old dilemma in this way. Polygonal shapes and features on the dwarf planet's surface indicate that it's a young and active geological system. The surface is only a few thousand years old despite the dwarf planet's 4.5 billion-year-old age overall. A thermal convective overturning of the ice is most likely the cause of this action. These are only a few of the discoveries made possible by New Horizons data, and more will be found in the future as scientists sort through the massive amount of data collected during the flyby. Space is limitless, and despite all the discoveries made by scientists over the past decades, more phenomena keep popping up, with each more intriguing than the last. Some of these discoveries include exoplanets and dwarf planets we didn't even know existed, while others are just bizarre UFO-like objects. In the search for more exoplanets, scientists with the aid of the Hubble Space Telescope have discovered an actual planet that has since been recognized as the 10th planet in our solar system. Further studies on the planet confirmed it to not only be the 10th planet, but also larger than Pluto. How did this 10th planet come to be? Could there be life somewhere within it? Join us as we explore how the Hubble Space Telescope confirms the 10th planet discovery and reveals it's larger than Pluto. Exploring the final frontier of the possibility of new phenomena has been fruitful over the years, with some leading to the discovery of planets surrounding our solar system. However, some of these discovered planets were later deemed dwarf planets, one of which is Pluto. Ever since Pluto became catalogued as a dwarf planet, scientists had only 8 planets recognized as of 2005. Since then, they continued their exploration in space, making new inventions and using them to make remarkable discoveries. This led to the detection of Eris. Eris was discovered in 2005 during a Palomar Observatory survey of the outer solar system. The survey was conducted by astronomers Mike Brown from Caltech, Chad Trujillo from the Gemini Observatory, and David Rabinowitz from Yale University. Spotted at the solar system's edge, Eris is a trans-Neptunian object and a member of a high-eccentricity population known as the scattered disk. It orbits our Sun at a distance of 96.4 astronomical units, making it the farthest object except for some comets. It was discovered by the data obtained from the Palomar Observatory survey in 2003, but wasn't noticed immediately. Upon discovery, it was nicknamed Xena until its name was changed after the Greek goddess of discord and strife, Eris. This name holds meaning as it caused several scientific disagreements and controversies. Astronomer Mike Brown explained the circumstances behind the planet's name, saying, "Eris is a goddess that stirs up jealousy and envy to create fighting and anger among men. One such example was at the wedding of Peleus and Thetis, where all the gods were invited with the exception of Eris. When she learned about her exclusion from the gathering, she spitefully caused a quarrel among the goddesses that led to the Trojan War." This name fits as the discovery of Eris was one major factor that led to the demotion of Pluto from being part of the 9 planets in our solar system and cataloguing it as a dwarf planet. According to Govert Schilling, a Dutch astronomer and science writer, he said Brown initially planned on calling the dwarf planet Lila. He chose Lila after a concept in Hindu mythology that described the cosmos as the outcome of a game played by Brahma. Also, it was very similar to Brown's newborn daughter's name at the time, Lila. Brown also had options for other names such as Persephone, the wife of the god Pluto. Eventually, it could not work as an asteroid had already been named 399 Persephone, so that ruled that name out. With no other options, the discovery team sent in Eris on September 6, 2006, and the IAU approved it as the planet's official name on September 13th. This name was peculiar to Brown for 3 reasons. 1, Eris had been regarded as a planet for so long, which assured him and his team that it deserved a name from Roman or Greek mythology like the others. 2nd, Eris was Brown's favorite goddess. 3rd, the name has not been used in the Greco-Roman pantheon that had been assigned to asteroids in the solar system, so it sounded like a perfect fit. Although finding out details about Eris was a bit difficult as it was so far from the Sun, determined scientists found a way by using a celestial alignment known as occultation. Bruno Siccardi, a scientist from the Paris Observatory, and his team began by calculating the diameter of Eris in 2010. The occultation happened as a result of Eris moving past a background star, therefore blocking the star's light and casting a small shadow on Earth. When the team analyzed the shadow size in Chile at two separate sites, both calculations gave a diameter of 2,326 kilometers for Eris. Before the 2010 Eris study, Saccardi conducted research on Pluto in 2009, and the outcome placed its diameter at least 2,338 kilometers. When Eris was initially discovered, the first estimates about the dwarf planet's size placed its diameter at 3,000 kilometers, but that wasn't the only outcome scientists relied on. In 2006, the Hubble Space Telescope joined with the Keck Observatory telescopes in Hawaii to measure the dwarf planet again. Its observations showed that Eris is slightly larger than Pluto, with a diameter of 2,400 kilometers. Achieving this measurement was quite difficult because for most telescopes the planet is very small and could only be identified as a dot of light. To get the measurements, the scientists working on the study waited until Eris was close to a star, then took 28 pictures of the planet. These photos were analyzed thoroughly by comparing the star and the planet, and eventually the Hubble Space Telescope came up with the answer. While learning about the dwarf planet, scientists made findings to see what was on the planet's surface. To do this, they studied the composition of far-off objects by looking at the sunlight reflected off them. For example, when the sunlight reflected off the Earth's surface is studied, it shows evident signatures of the oxygen in Earth's atmosphere, abundant water, photosynthetic plants, and other distinct features. Scientists used the Gemini Observatory on Mauna Kea, Hawaii, to study the light reflected from Eris's surface, and they saw that the planet looked very similar to Pluto. Eris's surface was very reflective, bouncing back 96% of the light that hit it. This makes the dwarf planet one of the most reflective bodies in the solar system, roughly similar to Saturn's moon Enceladus. Speaking of moons, a moon was spotted in orbit around Eris on September 10, 2005. It was discovered by a group of scientists with the Keck telescopes in Hawaii while observing the four trans-Neptunian objects: Pluto, Makemake, Haumea, and of course Eris. When the moon was discovered, it still had the nickname Xena, named after a warrior princess in a TV show. Scientists and astronomers believe that Eris's surface is likely to comprise a piece of nitrogen-rich ice mixed with frozen methane in a layer less than 1 millimeter thick. This layer could result from the dwarf planet's atmosphere condensing as frost on the planet's surface occasionally as it moves away from the sun. The new observations also allow researchers to make new calculations for the dwarf planet's surface temperature. Their study showed that the part of Eris which faces the sun is likely to get no warmer than minus 396 degrees Fahrenheit, while temperatures on the night side would be even lower. Although Eris has similar features to Pluto, they are not completely identical. Apart from their larger size, there are more ways in which these two planets have differences. For example, their surfaces. While Eris's surface appears almost white, Pluto's surface depicts a moderate red. Also, Pluto has a mottled-looking surface that reflects 60% of the sunlight that hits it on average. On the other hand, Eris has a different look and reflects differently. It appears uniform and reflects about 86% of the light that hits it. A fun fact about the characteristics of these planets is that they are not similar. As a matter of fact, Eris reflects the most sunlight from its surface compared to any planet or object in the solar system other than Saturn's moon Enceladus. This is because Enceladus has active geysers which coat its surface continuously with fresh frost. Considering all these, scientists could not think of any source of heat for Eris that could bring about small geysers. So how is it able to reflect so much light? After continuous research, they propose that Eris's bright surface and the uniform coloring of the planet are most likely the cause. As of this moment, the dwarf planet is as far away from the sun as it ever gets, making it extremely cold. With this distance from the sun, the planet's atmosphere is frozen solid. If Earth happens to move that far away from the sun, our planet's atmosphere will freeze up too. Scientists also propose that in 280 years, the planet would be at its closest, which would be a factor of almost 2.6 times closer. Also, the overall temperature on the planet would increase in the next 280 years by a factor of 1.6. In summary, the hypothesis by scientists says that Eris is bright and uniform due to its previous atmosphere, which had been frozen to the ground about 280 years ago. Scientists say this gives a bright, glistening coating to any previous form of mottled surface. Also, this freezing process is said to happen repeatedly with the planet's orbital period, which happens over 580 years. It is a reason why the whole atmosphere is probably only a few inches thick. Eris's far-off distance, along with its small size, is why it is difficult to observe the planet effectively without advanced technology. Presently, there are no plans of sending any spacecraft to fly by Eris soon, but powerful telescopes like the James Webb Telescope will be used for the task. As a matter of fact, the James Webb Telescope website picks Eris as one of its objectives and would also observe smaller objects in the solar system to see what their landscapes are made of. Let us know your thoughts in the comments section below. Everything we previously understood about Pluto, the planet beyond the solar system, has been completely altered by a recent display of wild fluctuation. When scientists explored Pluto, they found amazing features that had never been seen before in our solar system, unlike when it was previously thought to be an icy dwarf planet with little to no activity. It's amazing to know that we now have a deeper grasp of the world than ever before. Recent James Webb images that show planets in all their beauty have been made accessible by NASA, and they're simply outstanding, to put it mildly. What unforeseen discovery on Pluto was made by the James Webb Telescope? Could it be a hub for extraterrestrial activity? Previously regarded as the 9th and furthest planet from the Sun, Pluto is the largest known dwarf planet in the solar system. The unusual world is situated in the Kuiper Belt, a region beyond Neptune's orbit which is teeming with 1 trillion or more comets and hundreds of thousands of stony, icy planets, each more than 62 miles 100 kilometers across. Pluto was downgraded to a dwarf planet in 2006, ending its status as a planet. This reclassification sparked debate and controversy among scientists and the general public. Percival Lowell, an American astronomer, first proposed the existence of Pluto in 1905 after noticing odd anomalies in the orbits of Neptune and Uranus. Lowell reasoned that these ice giants' orbits must be off because of another object whose gravity is pulling on them. Lowell went on to predict the location of the enigmatic planet in 1915, but he passed away 15 years before it was found. Based on predictions made by Lowell and other astronomers, Clyde Tombaugh eventually discovered Pluto in 1930 at the Lowell Observatory. Pluto is so far away from Earth that until 2015, when NASA's New Horizons space mission completed a close flyby of Pluto, little was known about the dwarf planet's size or surface conditions. Pluto has a diameter of 1,473 miles, 2,370 kilometers, less than 1/5 the diameter of Earth, and is only roughly 2/3 as wide as Earth's moon. On the other hand, recent computer simulations reveal how Pluto is fortunate to be in the orbit that it's in, as the dwarf planet skirts close to a chaotic orbit that might perhaps destroy the beloved world. The orbit of the old 9th planet is unusually inclined and lengthy in comparison to the orbits of the other planets. Pluto really moves inside Neptune's orbit for 20 years of its 248-year voyage around the Sun. Azimuthal libration and latitude libration, 2 features of Pluto's orbit, prevent them from ever colliding. When Pluto crosses Neptune's orbit, it's always at least 90 degrees distant from Neptune, a phenomenon known as azimuthal libration. Latitude libration, on the other hand, makes sure that Pluto is always far above both the plane of the solar system and Neptune or any other huge planets when it comes to being nearest to them. These 2 elements work together to protect Pluto from harm. Planetary scientist Takashi Ito of the National Astronomical Observatory of Japan and Rino Malhotra of the Lunar and Planetary Laboratory at the University of Arizona have now improved their understanding of Pluto's survival in this particular orbit. Because of the 2 planets' 3:2 orbital resonance, which states that Pluto orbits the Sun exactly twice for every 3 times Neptune orbits the Sun, researchers discovered that Neptune predictably has the most influence on Pluto's azimuthal libration. The models, however, imply that Neptune has little effect on Pluto's latitudinal libration. However, when you add Uranus's gravity to the equation, things start to go south because Uranus acts to undermine both azimuthal and latitudinal constraints. Only these 2 planets could have caused Pluto's orbit to become unstable after tens or hundreds of millions of years, which would have caused Pluto to either collide with Neptune or, more likely, be flung out of the solar system altogether. Pluto is saved by Jupiter and, to a lesser extent, Saturn. Although Neptune and Uranus are further away from Pluto, their gravity is so strong that they can still dominate. Jupiter alone exerts enough gravitational pull to maintain Pluto's orbit steady for at least 5 billion years, which is how long the simulations were run. The surprising aspect of this new research is how small Pluto's zone of stability is, and how the dwarf planet's only chance alignment with the solar system's other planets allowed it to exist. Unofficially referred to as Tombor Regio, a sizable heart-shaped patch on Pluto's surface is another distinctive feature. Carbon monoxide ice has covered the left side of the area, which has the appearance of an ice cream cone. Within Pluto's heart, more differences in the surface material's composition have been found. The New Horizons crew informally refers to a remarkably smooth area in the center left of Tombor Regio as Sputnik Planum in honor of the planet's first man-made satellite Sputnik. This portion of Pluto's surface doesn't have any craters left over from meteorite strikes, indicating that it isn't more than 100 million years old geologically. It's likely that geologic processes are still shaping and altering this region. A few kilometers long and oriented in the same direction, black streaks can also be seen on these icy fields. It's possible the lines are generated by fierce winds blowing across the dwarf planet's surface. Pluto's surface is one of the coldest regions in the solar system. Around minus 375 to minus 400 degrees Fahrenheit can be experienced here. Pluto appears to have gotten redder over time, possibly as a result of seasonal changes when compared to earlier images obtained of it by the Hubble Space Telescope. There is some evidence that Pluto may have had a subsurface ocean, but this is still up for debate. The existence of the subterranean water may have had a significant impact on Pluto's past. Scientists discovered, for instance, that the zone of Sputnik Planitia altered Pluto's orientation because of the area's large concentration of ice, which New Horizons calculated to be around 6 miles thick, 10 kilometers thick. However, looking at less plausible alternatives, the researchers noted that a subterranean ocean is the best explanation for the findings, although a thicker ice layer or changes in the rock may be to blame for the shift. Images of a region with 2 large mounds that scientists think are ice volcanoes are being looked at in a fresh research. The surface surrounding these mounds was probably produced by relatively recent activity of the ice volcanoes or cryovolcanoes, according to the study's findings. The discovery suggests that liquid water or something similar may still be flowing or may have recently flowed beneath Pluto's surface, and that these volcanoes may still be active. Additionally, recent activity suggests that Pluto's interior is likely warmer than previously thought. The scientists claim that their findings could potentially increase the likelihood that there is life beneath Pluto's surface given other recent discoveries. Photographs of a region dominated by the Wright Mons and Piccard Mons, 2 sizable mounds believed to be cryovolcanoes, were examined by the researchers. Compared to Piccard Mons, which is roughly 4 miles, 7 kilometers high, and 150 miles, 250 kilometers wide, Wright Mons is a mound that is 2.5 to 3 miles, 4 to 5 kilometers high, and about 90 miles, 150 kilometers wide. The peaks of the alleged ice volcanoes also have extraordinarily deep depressions. The Wright Mons depression is nearly as deep as the mound itself. The terrain also has a distinctive lumpy or hummocky appearance in several places, made up of undulating, spherical mounds. These 2 large mounds may have developed over time as a result of the accumulation of smaller ice volcano-formed mounds, according to the researchers. According to Kelsey Singer, a planetary scientist at the Southwest Research Institute in Boulder, Colorado, there were no other areas on Pluto that look like this region, and it's totally unique in the solar system. This region of Pluto features fewer or no impact craters than other regions, which suggests that the surface was produced relatively recently in geological time. The paucity of craters suggests that the region is only 1 or 2 billion years old, with certain regions possibly being as young as 200 million years. Cryovolcanoes resemble volcanoes on Earth in certain aspects because Pluto has a large portion of its surface covered in ice and because its temperatures are much below the freezing point of water. This implies that liquid water or something similar that is at least somewhat fluid or mobile would behave similarly to magma on Earth, rising to the surface following an eruption and solidifying or freezing. It's probably not coming up completely liquid. It's probably more like a slushy thing where you have some liquid and some ice, or it could even be more like a flowing solid. Singer said, which could be more like ketchup or silly putty. It could even be more solid ice that can still flow. We all know that ice can flow because we have glaciers that flow on Earth. she said. Cryovolcanic activity on Pluto is presumably driven by radiogenic heat produced by the disintegration of radioactive elements in the dwarf planet's interior, despite the fact that scientists don't fully understand how it might function. Pluto lacks plate tectonics, the intricate system of moving continental crust that underlies geologic activity on Earth, but a similar event is one of the sources of heat in the Earth's interior. General tectonics, which may still produce characteristics like faults in rock but lacks tectonic plates, is the term used by scientists to describe geologic activity like that on Pluto. The shield volcanoes on Earth, which are low-profile volcanoes formed by the slow buildup of lava flows into rounded structures, have several characteristics with Pluto's cryovolcanoes. Instead of thinking of an eruption like Mount St. Helens or Vesuvius, picture the volcanoes on the Hawaiian Islands. However, unlike what scientists believe occurred on Pluto, shield volcanoes often emerge from incredibly liquid lava. A caldera, which is a depression in the center of some volcanoes on Earth and other planets, is created when a newly erupted volcano collapses into the space left by all the debris it spewed forth. Even though Mauna Loa, a shield volcano in Hawaii, is one of the greatest volcanoes on Earth and has a relatively modest caldera, the two structures are similar in volume. The depression on Right Mons is so deep that the volcano would have had to lose almost half of its volume to be similar in shape. There is still a lot that is unknown about these structures, their formation, and Pluto's cryovolcanism. Given other research that suggests Pluto was hot when it first formed and may still have a liquid ocean beneath its icy surface, the idea that liquid water could exist beneath the surface of Pluto raises the chances of life existing on Pluto from practically non-existent to slightly more plausible. And scientists are interested in learning more about our own planet in addition to worlds outside of our solar system. Additionally, the other NASA solar system projects are really enhanced by the James Webb Space Telescope. With the aid of Webb's groundbreaking advances in sensitivity and resolution, data at various wavelengths and from many sources can assist us in constructing a more comprehensive picture of Pluto. Asteroids, comets, and Kuiper Belt objects will all be observed by the Webb telescope, in addition to Mars and the large planets, minor planets like Eris, and even the tiniest bodies in our solar system.